Question 19. So this diagram shows the relations of the three sets. So set x, y, and z. So it basically means that this is something like a composite functions. So it's given that f of x is 2x plus 3. So it's good that we write it down. So this is 2x plus 3, starting from x, right? Okay, because it's the f functions, and we know this is f. And they say that G inverse f. How? Wow. So G inverse f. It means that G inverse f, basically they tell us that we're going to go for f first. After we done our f, we go for G inverse. So it means that we do f first. So after we go f, we go for G inverse. Means it's going to this way. And the answer is just 3 over x plus 1. So if you ask me that why is it this one not reversed, because they themselves give it to us the question that in this direction is already the G inverse. So it means that if you want to reverse again one more time, this is eventually the G inverse of inverse. So inverse of inverse is the just G. Okay, don't confuse with this one. So now they say that if a student write A is equivalent to 10, determine whether the value is correct or wrong. Give your reason. So now you become the teachers. So they say that if now A is 10, so we try A is 10. Is it correct? How can we identify? Yeah, we know. We know that if we receive 3 as our input, we will process it by using 2x plus 3. Because this is the function for f. F is going to process by using 2x plus 3, right? So we try to input 3 and see what can we have. So 2 times 3 plus 3, which is 6 plus 3 is 9. This student is wrong. It's not 10, right? Supposed to be 9. So we say that is wrong. Because f of 3 is supposed to be 9. So next they ask us to find G inverse of x. So don't forget this is the G inverse f. Maybe let me write it down so that it's easier for you to see now. So this is G inverse of fx is equivalent to 3 over x plus 1. And we also have the function of fx is equivalent to 2x plus 3. Now it looks a little bit cleaner. And they also to find G inverse. G inverse is the function in the front, right? How to do front again? Again, boring. It's just fish. So FIS hash. Whether you want to find the function is at the front? Yes, indeed it's at the front. I inverse the normal functions. So it means that we're going to inverse this one, which is the normal one, right? This is the normal functions. So again, what's the inverse? Learn it yourself, right? So let y is equivalent to 2x plus 3. Then we interchange the x and y. X is equal to 2y plus 3. Then y is equal to x minus 3 over 2. I will speed up a little bit because it's getting boring now. Then after we done the inverse, we substitute into the composite functions. So we know if we want to find G inverse, which is the front functions, is going to be just substitute this one into the composite functions. So we're going to substitute in. So x minus 3 over 2 plus 1. So if you're curious like how I did this one, because the x is at the denominator, so we just directly plug it in, okay? We just plug it in here. So how do we do this kind of things? It's very easy. In primary school, we say that if you have a whole number, it's not fractioned, eventually the bottom is 1. But there's no divide in fractions, so we have a times. But we know if divide become times, we need to flip the fractions. So this one becomes 2 over x minus 3 plus 1. So we just do 6 over x minus 3 plus 1. But don't forget to mix it up. So again, if we have whole number, the bottom is just 1. in order to make them the same denominator, we times x minus 3. So x minus 3, 6 plus x minus 3. So now we will have x plus 3, x minus 3 as our final answer. Next question, question 20 now. So we have 3 dice of the different color are thrown. The number obtained by red, yellow, and green dice are 6, 6, and 6. Wow, triple 6. Draw an arrow diagram to represent the relations of the set, the color dice thrown to the number obtained. So means that we want to know how do they relate from the color dice to the number. So what kind of color dice that we have? So eventually we have red, yellow, and green. Red, yellow, and green. And what are the numbers that we have? 6, 6, and 6. Wow, everything is 6. So we just have 6. Then we just need to put the arrow. So red we get 6. Yellow also gets 6. So green is also 6. Is it 666 is the devil numbers? Not so sure about it. I believe it's not. So now, hence that the type of relations. So you see, everybody go after 6. So this is so obvious that this is many to 1. Is this relation a function? Yes. How do we know? As long as the relation the back is 1, that is the functions.
Hey, if you have any questions or would like to see any kind of video, do leave your comments below and let me know. If you want to support us so that we could make more videos like this, the simplest way is just by sharing the video with your friends. Click the like buttons and consider subscribe to this channel. See you in the next video.